let's talk about attaching another sensor to Arduino and also utilizing the full capability of the breadboard like as a prototyping platform. I have this code that is pretty tightly based off of the code that I provided for Project 1. And just to verbally go over what each thing means, I did leave notes in that code for Project 1, but if it helps you to understand better, I think I'll just go ahead and explain each line and how it works. So before any of my setup or loops that I have going on, I'm going to establish something called an integer. And an integer is a variable. So there's two types of integers I have here. There's the constant integer and then just a regular integer. Constant integers never change. Now constant integers, here are my touch sensor, which is assigned to the digital pinout 10, and my LED, which is assigned to my digital pinout 6. Nothing about this will ever change. But I have integer touch state, and that has the opportunity to change between a high and a low reading, or on or off. We don't necessarily need the constants here before these integers, but what it tells me is, or as someone who, if I gave you the code, it would tell you that nothing about these variables will ever change, but they play a role in the code. So void setup, just to recap, void setup will essentially set up your code. It will run once and it will never run again. It sort of establishes like the rules of who's playing what role and what things are doing. So the first rule that I have is I want the Arduino to run a serial monitor. And what serial monitor does, it's actually down here at the bottom, and we can activate it by going to Tools, Serial Monitor. I want it to run and record what is happening on the board, so not only can I see in real life what's going on with the board, but digitally it will tell me if something is happening, recording data, and really just kind of troubleshooting. It's great if you have hooked up something and it's not working and you don't know why. Serial monitor is awesome, but also you don't necessarily need it, but it's very helpful. Then I establish the touch integer as an input method, meaning the Arduino will be reading what is coming from the touch. And I established the LED as an output method, meaning the Arduino is telling the LED what to do. Cool, so that's it for our setup. And now I have a loop, so this will run over and over and over until I unplug the Arduino. So first thing I do is I bring back the integer touch state, and I tell Arduino to read what's going on with touch, otherwise, pinout 10, read what is the status, and that will equal touch state. This made up variable touch, it could be, we could call it doggy. So we could call it literally anything you want. So if the so doggy is now my new variable name, equals whatever Arduino is reading from the touch sensor. So if doggy equals high, meaning if touch sensor is being active. Then I want serial print to print out below, and you'll see how that works in a little bit. I want it to print out touch is on, LED is on. And then I want it to write a command to LED. And that command is high. So write out to LED, high or on. If doggy or if touch state is red is on, do this. Else, so if this is not happening and anything else but this is happening, so anything but the touch sensor being active is on, then I want the code to do this. I want the serial print to tell me that the touch is not being activated and the LED is off. Then I want Arduino to tell LED to go into low state or off. And then a short delay and then run again. So just for the sake of knowing how much you can manipulate code, I will leave doggy in as that integer. But we can also change, say you want your LED to turn on when the touch state is not being active. We could switch this simply to low, meaning that the touch is off, but the LED is on. Else, meaning if anything else is happening, that means the touch is going to be on, the LED is off. So you don't have to play with linear interactions, meaning I do X and Z occurs. It could be more like you're stopping a command with your touch sensor, or you're stopping a command with your any sort of sensors. For project 1, you have interaction as the focus, but the interaction doesn't have to be I do this so an output is executed. Maybe you're stopping an output from being executed, if that makes sense. So I'm just going to change this back to, I want touch on to read as LED on. So let's get the camera on the desk going. All right, cool. So let's talk about what is here. So we have Arduino, but we have this touch sensor, and if I can get it to focus. What's going on here is we have 3 pinouts. We have the ground, we have the VCC, that's the voltage in, and we have signal. And signal is basically touch on or off. And then we also have this tiny, tiny little hole right here that you can stick a jumper cable or a copper wire in, and it goes through. You could solder a cable or a wire right to that and extend your touch sensor. And I will show that in just a second. So let's get everything hooked up. And I'm just placing my touch sensor right inside the these data lines, getting my LED ready, and my resistor. Remember that your resistor, it can go at the beginning or the end, the positive or the negative, it doesn't matter, but I like to put mine at the positive. So LED is assigned to D6. Remember, data goes horizontal through these rows and columns, and it goes vertical through these positive and negative columns. So data is driven from this point to this point, and on these numbered and lettered rows goes left to right. And I'll show you how we're going to use some of these, like the positive and negative sides of the breadboard. So I'm hooking this up in like no particular order. Actually, let's move her down to there. Red is hot. And then moving down the line, I'm plugging in the red to the 5-volt in, and that is right here. Okay, and then we'll ground our LED. So this is using these vertical strips with the positive and negative. This is a good way to hook up a lot of sensors. And then don't forget to ground out to the Arduino. Boom. Let's move this just over here. Okay, looks good. Let's plug her in. And send the code. Oh, I forgot one thing. The pinout for the touch. Okay, now everything is plugged in. All right, so you'll see on my screen that serial monitor is reading touch is off, so LED is off. And I'll go ahead and just demo that. Touch is on, LED is on. Touch off, LED off. And again. Pretty simple. But I do want to show you guys about, or talk about like the copper, the conductive materials that we can use. And this is plastic on this side. This is like a vacuum form styrene with, on the inside I laid copper tape. And we have copper tape in the class. And you can line materials with it, or even just like embed copper wires into, soft materials. But on this side, this is just plastic right here. And I think I didn't solder, I just taped in a copper wire to each side and then crudely soldered some jumper cables together. So I'm going to use this as my new button. And remember the hole on the back, or that goes through the touch sensor? I'm going to plug this in. Okay, cool. So I think it just took a second to orient itself, and like if maybe there's some like interference or something, but I'm putting my hand over this little piece of plastic lined with copper. LED goes on. Remove my hand, LED goes off. Hand on, LED on. So this is a good way you can extend the range of your capacitive touch with really simple materials. Like I said, like fabrics, or even just like this, plastic. So test out what is, what else can you make conductible in order to activate your sculpture. So cool.